Well, welcome everyone. I'm so excited to welcome you all to hear from our colleagues today about best practices for preparing students for a career in business analytics and data science. This is a redo of a panel that happened over the summer for the JSM conference, and it was great. And so we wanted to give another opportunity for more folks to be able to hear from this panel. And so I'm going to turn this over to Dr. George Reck in a moment, and he'll introduce our panelists and sort of be our host. During this panel discussion, if you've got questions, if you would type them in the chat or the Q&A, your questions will come to me, and at various times throughout the session, we'll pause and I'll read off some of those questions and we'll get answers for you. So at any time during the session, feel free to post your questions in the chat or the Q&A, and when we have an opportunity, we'll go through those questions. So again, thank you for joining us today and welcome. We really appreciate our special panel being here today, coming from ASA's Business Analytics and Statistics Education Group. And they're joining us in our regularly scheduled JUMP academic webinar series, which we put on throughout the year generally to teach topics about statistical analysis using JUMP software. Today we won't be talking about software, but we're very excited to hear from our panelists. So George, I will kick it over to you.
All right. I hope everybody can see my screen. On behalf of JUMP and ASA and the Business Analytics and Stat Ed Group, I want to welcome you today. My name is George Reck. I'm the chair of that group, affectionately known as BASE. So as Ruth said, our topic is best practice for preparing students for a career in business analytics and data science. And the interesting question around that is it's quite a bit a moving target. And as companies embrace business analytics more and more and deeper, academic institutions struggle to try and keep up as best they can. And we've got 3 excellent panelists today that will hopefully do just that for your enlightenment, give you a better idea of what's happening in terms of both the business side as well as the academic side. The panelists that we have are first up will be Kim Hoffman from Genesis Equipping Ministries, followed by Roger Hall from Union College, and then Michael Posner from Villanova University. At this point, I'm happy to kick it right off to Kim, and Ruth, I ask you to switch over to allow her control.
Well, good morning, afternoon. I'm in Colorado, so it's morning for me. And I just wanted to share a little bit about my experience at DuPont. George introduced me as Genesis Equipping Ministries. That's since I retired this year, very recently. But the context of this sharing will come from my experience with DuPont Applied Statistics Group for 30 years. Just a brief context of how statistics was positioned within DuPont. Best way to describe what we were looking for in statisticians or data scientists would be to look at our job descriptions. So I'll share a couple of those, one from the Applied Statistics Group and one from our R&D organization for a data scientist, and then put them together and show a chart on what we think is best for preparing students to meet either or both of these needs. The Applied Statistics Group was within an engineering function within DuPont. You can see there are lots of different engineering capabilities, and that's where statistics was positioned within the DuPont company. I guess that's kind of consistent with the thought of statistics being statistical engineering, because that's really what we did, is we tried to leave behind as comprehensive solutions to problems as we could. Looking at about 6 years ago, because DuPont has gone through in the past 5 years so many transitions, in a merger with Dow and then a splitting up into 3 different corporations. So I think to get kind of a stable picture of what we're looking for, this is what our group looked like 5 or 6 years ago. We had 20 professional statisticians supporting all of DuPont globally. These are the expertise, a wide variety of expertise used across the company, but the ones highlighted in yellow are really the ones that are most universally applied. So you can see a lot of design of experiments and modeling, advanced mixed modeling, optimization, a lot of quality work in manufacturing, and along with that went Six Sigma, training and mentoring, software, of course, measurement system development, and we did all the training throughout the corporation. Of course, we need statistical software. DuPont was using Dow this year. DuPont was using, because we merged with Dow, was using JUMP software throughout the corporation. Just showing you, we did most of our work in innovation or in new product and process development. And so that's how I highlighted what are the most specific statistical techniques used. And this chart comes out of a paper published with Will Jensen a couple years back. But most of our statisticians, professional statisticians, work where things are a little bit more complicated, and that's in the R&D or development arena. So we have, so the scope of your involvement depends on or will determine the breadth of the solution that you can offer to a problem. Sometimes we're just asked, here's a data set, can you analyze the data for us? In that case, your role is more of a number cruncher. We don't have a whole lot of that going on. In the R&D organization, they actually do a lot more of that than what I'd call statistical engineering. More often, we're asked to be part of a consulting team that will design and analyze the data set. So a lot of, again, statistical design of experiments there. There you're more of a team player on a development team. Many of us were playing the role of the project leader, actually, in either improvement projects or more likely my job for the last 10 or 15 years was to lead integrated teams developing new products or processes. So we did, we had the marketing on the team, we had the product and process development, the sales, all the way through from idea to commercialization. And there your role is a whole lot more than just statistician. It's an integrator. And then as I was leaving, I was getting more into actually the portfolio manager for a lot of different projects together. And you might be approached there saying, look, the market's demanding this new product performance and these new features. What should we do to meet this new need? And so then you're looking at a portfolio of projects. So the kind of skills we're looking for, more a new person, young person would be, well, new and less experienced person, I should say, would probably be in the top part of this chart, but we'd be looking for them to be able to mature into the skills on the bottom part of the chart. And so we recently were looking last year, we were looking, or the beginning of this year, I guess, COVID changed everything, but we were looking for a statistician to hire, and we were going to work through an internship program. And so the roles and responsibilities we were looking for are here. Again, draw your attention to the ones highlighted. Basically being able to work independently and be your own consultant, work on cross-functional teams, take and teach short courses, and learn project management would be an opportunity, again, to develop them into those roles lower down on the previous chart. Oh, I think I missed. Okay, so what did we look for? We looked for them, we were looking for master's students or pre-PhD students, strong interpersonal skills. These are the coursework. This is a coursework list that we were looking for. Again, they wouldn't have everything necessarily, but things in this list are most important. General statistics, hypothesis testing, and a lot of design of experiments, modeling, and so forth. Getting down at the bottom of this list, you see predictive analytics, general machine learning, and operations research. These are things that were more recently added to our list, partially because of there's another organization. So that was the applied statistics group within that engineering organization. We also had another R&D, information and analytical sciences organization that provided a whole lot broader computing support, but they had an arm that was data science and analytics. And there they were looking at a lot more of the skills necessary to do things like Internet of Things kind of applications. We were putting a lot of electronics into materials to make them smart and so forth, and the capabilities required there would be added. So again, the highlighted areas there. Having trouble changing my screen. This is their organization. They had a whole bunch of text analytics folks, Internet of Things capabilities, but in the middle here, this lab data analytics is really where the statistician would reside. A lot of the same kinds of skills, but looking at more machine learning, deep learning kinds of technologies added to that, and different kinds of software. It's almost like another branch of statistics growing within DuPont. So what were they looking for in their jobs? They were looking for, again, general statisticians, design of experiments, but again, okay, wait a second, am I going down? All right, went the wrong way here. They're looking for the same kind of skill sets, basically turning data into critical information, but the kinds of skills that they were looking for leans heavily toward computing. And so a lot of the machine learning techniques, a lot of coding skills, they don't use the same kind of statistical prepackaged software that we used as much. So if I put that all together, in what were we looking for in a statistician or data science person at a place like DuPont? The things on the left were more for the industrial applications. The things on the right are more for the emerging machine learning kinds of applications. And what's in the middle is needed for both. So really strong in data analysis and visualization, have experience through co-ops or internships, working with teams, and strong communication skills, and general business acumen. They have to kind of understand how things work. So depending on whether they were going to be more working with the sites, well, it depends on the kinds of problem, actually, that they would have, whether they would need to lean more to the left of this chart or to the right of this chart. But both are being hired within DuPont. And across the board, they need to be good at project management and consulting skills in general. So that's how we see preparing what's necessary to prepare students for work in DuPont. Back to you, George.
Well, thank you very much. Ruth, do we have any questions in the queue, or should we keep moving?
We do have a question. Our first question is, the DuPont split between statistics and data science seems to match the academic split between traditional statistics and big data fields. Has industry been any more successful at bridging this gap than academia?
No. In my experience, I mean, the short answer is no, not really. We were partnering very closely with folks, and we started working on the same problems together. So that was the way that we were doing this. I actually led a whole initiative on Internet of Things for electronics business. So, but I don't personally have the machine learning background, so I would partner with people and bring that expertise in. And so we were working together, but as far as that being combined in one person, not very well. That we're kind of, because we're hiring from, and this is where I was really interested in seeing this talk and this, the quest for this kind of a presentation is, what do we see as the need? We need to see some of that integrated in our preparation of students, and I'm not seeing that. And I'm more seeing a switch away from strong industrial statisticians. So if we want to hire somebody that knows some machine learning and those kinds of skill sets, they seem to be lacking in the experimental design and traditional statistics. And we don't see that as a good thing, that we think both is really needed. But I don't see it as happening yet. I think academia has to do it first so that we can hire the right people.
All right, we've got one more question. Would DuPont or other similar types of companies be open to talking to students in classes about the skills they might be looking for in general in candidates, or are there contact? How does a professor go about finding folks like that to speak to their students? Before you answer, I would like to mention that this is being recorded, and so this is one resource that will be out there that you can certainly have your students watch in the future. But Kim, if you have any insight on how a professor could get in touch with folks like you to be speaking to their students, that'd be great.
They can get in touch with me directly. I'm sure Roger would be willing to talk. I'm sure any of the panelists would be willing to speak with anybody. As was mentioned already, I have retired from DuPont, so if you wanted to connect with somebody at DuPont, I could give you a connection there. Unfortunately, with my retirement, the Applied Statistics Group is no more, but the data science is still hiring and looking to backfill, and the businesses are going to be looking to backfill some of, in time, some of the applied statistics skills, so I can connect you there as well.
That's wonderful.
Contact information, I guess they can get that from
Yes,
you?
everyone is welcome to send an email to academic@jump.com. I'll put that slide up also at the end of this session to remind you of that email, but academic@jump.com, and I can pass on your information to get in touch with the speakers if you need that. Kim, as an academic ambassador for JUMP, I come across these kind of questions all the time about how do we get more industry speaking with academia, so I really appreciate your answer for that question. We have one final question for you. With integrating data science with traditional statistics, what coursework would you recommend for first-year grad students or for professors teaching first-year grad students to incorporate into their curriculum?
Ask the first part of that question again, because I think that's my last chart. Like I had coursework, I'd say if you have a basic in statistics, experimental design, add some machine learning in there, some basic programming in Python probably would be a good thing.
Perfect. That's a great answer. Thank you so much.
Mm-hmm.
All right, George, back to you.
And really, it's over to Roger.
Okay.
If you would hand Roger the ball, Ruth, that would be wonderful.
I will do it.
Great. Well, thank you very much. I'm going to grab my file. Give me 1 second. For those of you that don't know me, while I teach at Union College, I spent the vast majority of my career in the private sector, the last 17 years at GE. So I'm also coming at this from more of a private sector perspective, although I've been at Union College since 2012. So I want to talk about what are the desired skills? That is, what's the product we're trying to produce? And that involves technical, leadership, and critical thinking skills. And then I'll talk a little bit about the process, or how do we produce that product. So from my point of view, the three macro areas of desired skills are technical skills. I think that's obvious. But then there's also leadership and team skills. And these are skills that are very well understood and valued in the private sector. People actually look for them, and on interviews, the team will discuss behind closed doors, hey, do we see this person as a leader 10 years from now? Might they be in a higher position? And then third is critical thinking skills. This third one is critically important, but it's not talked about a lot. And I think that's a big area of potential differentiation. So in terms of technical skills, Kim talked about these. I'm not going to go into detail. The traditional statistical stuff like design of experiments, yeah, it's still needed. It hasn't gone out of style. It's going to be here for a long time. And then, as she said, machine learning, coding, Python, R, cloud computing, those are important skills. Not everybody has to have every skill. There's the so-called data science unicorn. Nobody has all these skills, so you don't have to. And then third, subject matter knowledge, if at all possible. So if you're going to work in finance, it'd be really good if you knew something about finance. If you're going to a pharmaceutical company, it'd be really nice if you knew something about biology. So you don't have to have every skill, but what most people are looking for is what's called the T-shaped candidate, which means they're broad and can do a variety of things, but they're really deep in one area. They're not expecting you to be deep in every area. So in terms of leadership, what am I talking about? Well, things like taking initiative. A lot of people can take direction, but taking initiative is a little harder. Being able to get things done. And as a technical person, negotiating a collaborative relationship versus consultative, meaning I'm an actual member of the team, not just somebody that gives advice. And then effectiveness on teams, working well together, not being egotistical or the know-it-all or the no person that tells everybody, no, you can't do that. And then being an effective communicator is often overlooked, but I would argue this is one of the most important skills to advance your career in the private sector, is that you can, in writing and in person, convey your ideas, especially to non-technical managers. A tech CEO once said, I don't hire jerks, no matter how smart they are. They didn't use the word jerks, but I'm not going to use the word they used. You get the impression. So in terms of critical thinking, what do I mean by that? Well, problem solving. Many people, data scientists, statisticians, get a really deep education in tools, but not so much on, well, how do I solve a problem, especially one that's unstructured? Not unstructured data, unstructured problems. Can I get past symptoms and diagnose root causes? Now, this whole problem-solving viewpoint is more of an engineering than a science viewpoint, because it's not focused on individual tools. And then it may sound obvious, but just having an inquisitive mind, asking questions, thinking about cause and effect. Well, why is that happening? Well, what would happen if we did this? No matter how well you know the tools, if you don't have an inquisitive mind and ask questions, you're probably not going to be successful. And the third one, they don't teach you this in grad school, but if you can keep a cool head in a crisis and say, well, wait a minute, guys, before we panic, let's take a look at the data. Let's look at and see what it's telling us. People will start relying on you when the chips are down. When you're in a difficult situation, they will realize, well, this person doesn't panic. They actually take time to look at the data. So I think this is the area, not that the others aren't important, but it's a true area for differentiation because everybody else doesn't have this. Now, in terms of the engineering problem-solving viewpoint versus the tool-based viewpoint, this is a slide I blatantly stole from Michael Jordan with permission. He gave this slide at a talk at the University of Michigan in 2019, and he talked about statistics as a problem-solving culture, that engineers generally pride themselves in solving problems, whereas statisticians don't typically think of themselves as being engineers. They typically view themselves as scientists discovering truth, whatever that means. But as Jordan pointed out, society really needs us to solve big problems, not just to know tools well. And so he challenged the audience at the end to embrace being engineers and think about what statistical engineering would look like as a counterpoint to statistical science. And there is actually an organization, I'm involved with it. It's called ICEA, the International Statistical Engineering Association. It's free to join, and we're trying to dig into this a little deeper. We took what Michael Jordan said very seriously. We think he's onto something. And so we're trying to dig into that a little deeper and see what exactly would this mean to have an engineering mindset in addition to a scientific mindset. Now, let me switch gears and talk about, well, how would you actually develop these skills, given you're not going to do a course on how to keep a cool head in a crisis? So classroom instruction can get you part of the way there, but in my view, it can't get you all the way there. So some other things to consider are internships, where people will work on real problems, preferably on teams, so they get the teamwork aspect. And then you can have focused seminar series on things like soft skills. For example, how to give a PowerPoint presentation to a senior executive who may only give you 30 seconds to get his or her attention, and then you're done. So what do you do in that first 30 seconds to get the senior executive's attention? And then things like a thesis, summer projects, where you're perhaps working on a real problem, something that needs to be solved, not an analysis of a given data set, but a problem, and you have to think through what's the diverse set of tools I might need to use in order to address this problem. Net, as I say at the bottom, I think we just need to be creative and think outside the box at how can we come up with ways to develop these skills, given that we're not just going to add 5, 6 courses to an existing curricula. Now, having said that, I think we also can modify the course instruction, what we actually do in the classroom. One of the things I'm trying to do, and with mixed success, I think I'm doing it to some degree, could do better, is actually require critical thinking and problem solving. Now, I'm in a small liberal arts school, so I don't have to give true-false tests and multiple choice. I give a short answer, and I ask people why they think that should be the right answer and how they would approach this problem. That forces them to think through, why am I taking the steps I am? How does that fit into a bigger picture? What's the rationale for that answer? And some of the questions I ask, there isn't a correct answer to. There's a variety of ways you could approach it, and I'm really looking for how they're thinking about solving the problem. And then for every class I teach at Union, I require a course project that has to be written up. And if it's a team project, they have to do an oral presentation of it. So this forces people to learn how to write, and I require them to explain things in plain English as well as in statistical terminology, so they get that experience of presenting and writing technical topics, but in a non-technical language. And then you could also give team assignments. For example, you could assign a team of people to work on a Kaggle competition. So basically, what we can try to do is help them understand the engineering aspect of statistics, of how to think about attacking a problem, in addition to the scientific part, which is deep knowledge in the tools. And of course, deep knowledge in the tools is still important. I'm not saying forget about that. I'm just saying let's augment it with a set of tools, a set of thought processes that are going to help people think through how to attack these large, complex, unstructured problems that many of us, Kim and myself, faced when we went into the private sector. So to summarize, businesses are looking for analytic talent with broad skill sets. Like I said, what's ideal is that T-shape, not just one area, but broad enough that you can work on different types of problems, but you have that depth in a given area. I think the ASA just put out some statistics about the number of bachelor's, master's, PhDs in statistics. They're all going up, especially bachelor's, because there's demand. The private sector needs high-quality people, but technical skills are not sufficient. They're mandatory. They get you in the game. Without the technical skills, you're not in the game. But there's a lot of people out there that have strong technical skills, and so it's pretty difficult to differentiate yourself on pure technical skills. If you can augment those with critical thinking skills that you can demonstrate to corporations that you're good at thinking through how to attack a problem and getting to an answer, not just that you know how to code in Python, which is great, but can you take that Python coding and utilize it to actually solve a real problem and make that solution sustainable? So to create this type of person that has additional skills, leadership skills, critical thinking skills, I think there's no one solution. There's no one magic bullet that's going to solve this. So I think we need to modify some of the traditional lecture classes to require more critical thinking and more engineering viewpoint of tying together various tools. And at the same time, we need to add additional venues or opportunities for people to develop these skills. So thanks very much for your patience. And if we have time, I'd be happy to answer any questions.
Ruth, do we have any questions?
Yeah, we do. We have a question, a little background of the question. The questioner first mentions that computer programming involves a particular type of critical thinking, like logic and organization. But critical thinking about data is broader than that. And then the question is there a conflict between devoting a large part of the educational process to learning programming versus learning how to critically think about data?
I think there is, and this is my viewpoint on things. When engineers, say mechanical engineers at Union College, ME majors, when they take calculus, they don't get it from mechanical engineering professors, they get it from math professors. Why? Because math professors know math best. So if we think about coding, I don't think statisticians are the best people to teach coding. I think computer scientists are the best people to teach coding. And so in one of the courses I teach in big data analytics, we use R, but I'm not a computer scientist. I'm not an expert in good coding principles. So I think depending on the individual's interest, they might want to be really heavy on the coding and then light on the statistics if what they're really interested is the computer science aspect. But if they're really interested in solving real problems with data, they might be heavy on the data analysis material and light on the coding. Not that there is no coding, but again, everybody can't be an expert in everything. And in my view, there's a different niche for a computer scientist than there is for a statistician. They're not interchangeable. So let's let the computer scientists be great at computer science, and we ought to be great in statistics, realizing you need to know some coding and some math to do statistics.
That's great. We have another question kind of in that vein. Can you speak to this newer sort of focus of ASA on there being a problem with classical statistical inference methods and how, if they should be removed or minimized in coursework?
Sure. This is my opinion, of course, the only issue with classical methods is if we take a legalistic view of things like hypothesis testing and p-values and view it from a decision analytic perspective. Now, nobody that I know that I ever worked with in the private sector would treat a p-value of 0.049 and a p-value of 0.051 differently. I've never worked with anybody that would treat those differently. They're essentially the same thing. So in my view, if we look at p-values, for example, they're perfectly valid metrics as long as you realize what they are and what they're not, and you don't treat them legalistically. It's a benchmark. So with especially medium to small data sets, you still need that. I mean, if there's a legal case at Union on gender discrimination for professors, you're going to need some statistical evidence to make a case. Now, there are massive data sets as well, and if you have 50,000 data points, then, well, that's not really massive. Let's say a terabyte of data. There's really no sense doing hypothesis testing because everything's significant. It's kind of silly. So in my view, there's a toolkit and there's a variety of tools. And just like a good electrician, plumber, carpenter, they're going to look at the problem first and say, what's the nature of this problem? And then decide what tool they want to use. They're not going to start with their favorite tool and try to force fit it. So for small, like COVID testing right now with the clinical trials, we definitely need traditional statistical methods to design and analyze the clinical trials. That's not going away. At the same time, we realize for terabytes of data, doing a t-test makes absolutely no sense whatsoever. The key point being we want to broaden the toolkit and ensure that we have the right tools for the problem at hand.
That's great. We have one more question, I think from a student asking for a first-year graduate student. Do you have any idea of where a first-year graduate student could go looking for internships to get that experience you're asking for?
Sure. A lot of times the department, people in the department have connections to local business and industry, and they might be able to set something up for you. Even if it's not in your department, if you check with some of the other departments, like if you have a business school, you have engineering school, they're likely to have connections. And even if your own professors don't have those connections, you can ask them for their colleagues to see if their colleagues can find any such connections. Sometimes these things will be posted, so they'll be in Monster or Glassdoor or perhaps in things like Amstat News. But I would say the majority of them are going to come through connections, and that's why you want to rely on professors within your school.
All right, thank you very much.
Can I add one comment to one of those questions?
Yeah, that would be great.
Yeah, the question that, well, when Roger was speaking, it brought to mind an observation, and I really love the whole idea of critical thinking is what's differentiating. It seems to me, and Roger, correct me if you disagree, because it'd be nice to have a little debate. I don't think you will. That it seems industrial statistics or classical statistics started out very academic, you know, and over time realized the need for this breadth of knowledge as well as the depth, right? And so if you get a good applied statistics degree, you've got a lot of the communication skills. They usually involve a co-op of some sort or an internship, and you get a lot. What I observe is this data science field that's emerging, big data, all of that stuff is decades behind in that learning. That they are still very technical, and they're excellent. And even our PhDs that we were hiring were the best in their field at a specific capability, but they couldn't look at a problem and say, oh, this is the way to do this one, you know, and it's not machine learning, it's this, you know, that they just they haven't developed that understanding for the knowledge breadth that's needed even for their problems. So I don't know if you observe the same thing, Roger, but it seems like, you know, it's coming up from another field outside of statistics, and they haven't really learned the necessary breadth that they need as well.
Yeah, I would agree with that, and I would say, as somebody in the latter part of my life rather than the early part of my life, we learned a lot of this stuff the hard way.
Yeah.
We learned a lot of it by making mistakes and then realizing after the fact, oh, that was really dumb. Why did I do that? I should do it this way. And with the proliferation of people with more computer science backgrounds, data scientists, whatever you want to call it, that's a newer discipline, and they haven't had a whole generation of people learn all those hard lessons and document it in the literature and then put it back into the curricula. So right. I think it moves on to an important point.
Yeah, and so that, for me, if I'm hiring, I mean, if you're a student, maybe this is relevant to you, but if you're hiring, this might be more relevant, is I would look for the person, well, no, maybe I'm designing my own curriculum, you know, what do I want to do? I think I'd err on the side of taking a traditional applied statistics degree and add on the data science stuff, because then you'll get the more broad education you need, plus some of the data science. If you're a programmer, then you got to go outside of your field to get stuff.
Great. I think we should get moving on to Michael's presentation.
Can you guys see that?
Yes.
Great. Great. Well, thanks for having me. My name is Michael Posner. I'm from Villanova University. Before I get into my talk, I actually would love to add 2 comments to what Roger was saying as well. In terms of the classic methods and should we be using that, without a doubt, a well-designed study with a p-value is better than a well-designed study without a p-value. The problem is a lot of people focus on the p-value and not the fact of evaluating whether it was a well-designed study or not. So I think we need to spend more time on that, because getting the p-values are actually fairly straightforward. It's, is the study well-designed? Can you make the inferences you want from it? I think that's the important part of it. And in terms of the coding statistics question, I feel like with data science and business analytics, there's a real opportunity to integrate them. So in my programming class, I agree with Roger 100%. I am not the best coder in the world. And I will let my students know that frequently by demonstrating it to them. But when I teach the programming class, it's an opportunity for me to integrate the statistical thinking that I want to reinforce with them. So let's not just create the bar graphs that we want. Let's talk about how we handle the missing data. Why are they missing? What happens if we group the missings into each of the different groups? How does that affect our interpretation? And I would hope that our computer science colleagues who are teaching these data science classes would do that as well. I hope they teach me how to be a better coder, but also that they integrate the statistical thinking into their classes as well. That would be my addition to that comment. All right, so a little bit about me. I'm a professor, associate professor at Villanova University. I'm the director of the Center for Statistics Education there. I also am the chair of the ASA section on statistics and data science education. My data science journey, if you will, began on my sabbatical in 2015-16 when my wife, who's a professor as well, got an appointment at University of Cambridge, and I was her plus one. So I was the tag along. And decided it was a great time to really start improving my coding skills and get on the data science bandwagon. So after that, I began teaching data science courses at Villanova, and I have to say that it's by far my favorite class to be teaching right now. Students give me a lot of feedback saying this is the course that changed their career focus. Even first semester seniors take this class and say it changed their focus. It really empowers them to work with data in many ways. In terms of that, that classic statistics question about, and as Roger said, a t-test with a terabyte of data isn't useful. But I would argue that we don't need more complex methods. Often the mean is a good summary of the data. So let's not try and make things too complex statistically. Let's even simplify them more. The mean might be a good summary of the data, but is it the mean of the right measure? And how do we handle the missing data? And what are, if we're looking at multiple means, are there confounders, covariates that we want to be exploring as well? To me, those are really important things. I've done some collaboration with colleagues, have some NSF funding on data science material, and I've attended a number of national meetings on data science as well. One of the really interesting ones was an NSF meeting where they brought together folks from different disciplines to try and decide on what the curriculum should be for data science, and we all agreed that we couldn't agree. The computer scientists wanted more coding, the statisticians wanted more models, the business intelligence people wanted more end user stuff, so it's really hard to know what's right. Our business school uses JUMP a lot, and that's great, right? If they're doing, a lot of the atypical data manipulation, maybe it's harder to do there. But, as a front-end use, it's a fantastic program. So what is data science? Again, you guys have probably seen this already, but I always say that we can all agree that data science is the biggest purveyor of Venn diagrams. This is the classic picture that people talk about with data science. I like that everybody's jumping on the bandwagon. Even the graphic designers are trying to say that if you learn your data and your statistics, you'll be very well paid. And as Roger alluded to, maybe from my talk last time, this is my favorite one. That at the cusp of all three of them is really that unicorn. There was a talk that I went to at ASA a number of years ago where somebody said that, if I were to hire a person who's a data scientist, what I'd want is somebody with a master's in CS and a master's in statistics and a master's in the subject matter expertise. And I boldly raised my hand and said, have you ever met such a person? And he said, no, but that's what I would like. Well, great. The question is, as educators, how do we prepare students for those jobs if we're not going to give them 3 different master's degrees? And I think that's the challenge that I'm taking here. So what should we be teaching? I'm framing this as not the new courses that we can develop. Those are absolutely crucial. But even in our introductory courses, how can we shift what we're teaching so that we're really preparing students best for this data science analytics world? We need to make sure that we teach them about bias. And I really like this quote from Confucius and others, what you know, what you don't know, you don't know. This is true wisdom. So know what you know what you don't know. And to me, this comes out in 2 different ways. So my interest in data science was, as a statistician, I began to deal with data that I didn't know how to handle. And what would I do if I couldn't handle the data? I would stop, right? If it's a big project, maybe I'll consult a CS friend, right? But I would stop. I couldn't go further, right? A CS person, right, a good programmer who has a large data set and isn't well versed in statistical thinking is going to work the data very well and get the right answer to the wrong question, right? And that happens too frequently. I've seen a number of colleagues who are great coders who were doing an analysis of simple paired data, and when they analyzed it, forgot the pairing. That's not something that's okay, right? We obviously, data are paired. We have to view it that way in a graph. So know what you know what you don't know. The other one is, as we think about coding, both when we teach it or when our colleagues are teaching it, let's spend some time thinking about the implications of the choices we make on the statistical inferences. So do we throw out missing data? When we combine derive information from aggregating data, do we use a median or a mean? And why is one beneficial over the other? And what do we gain by doing one or the other? I find that often everybody wants to aggregate data and just calculate means, when in reality, the standard deviation can be really important as well. What does that tell us? Why might we want to gather it, right? So I have students who are always looking at how sports teams performs. And one of the interesting things we look at is the standard deviation of player ability. So if you have a couple superstars and a couple mediocre players, is that actually worse off for the team than if you have a bunch of people who are not quite the superstars, but play well together, have good chemistry? Clearly at Villanova, we think about good chemistry and lack of superstars, especially around March. Multivariate thinking. So we need to be thinking about in data viz. Again, I see a lot of people who know how to create the graphics, but they're not creating the right graph for a given situation. And that's problematic. So let's make sure we do that. When we talk about confounders in an introductory class and our CS colleagues, we don't need complicated statistical methods or machine learning tools to do that. Stratification works just fine, right? And in an intro programming class, perfect. Let's talk about stratification and look at graphs separately for each group and see if it changes. And of course, we want people to be thinking about causality. In terms of data analysis, there's two things that I remind my students of, and this is exactly what Roger and Kim have both been talking about the importance of doing projects. When we teach the technical skills in class, it's really easy for students to figure out what tool is appropriate. Because if I give them a homework in week 7 of my class, they know we're in chapter 5 of the textbook, so they just look at chapter 5 and say, oh, it's a 2-sample t-test. But in reality, that's the biggest problem that people face when they have an open-ended project. Well, what should I be doing, right? And so I talk about two things. One, building up your analysis. So start with univariate relationships, then look at bivariate, then build it to a more complex model, whether that's a statistical model or a visualization. Make sure you understand the data before you jump into the complex models. The second is this one-and-done fallacy. So again, if we're in chapter 5, right, they know it's a t-test. Well, that might be the right analysis to do, but that only answers one question. And a rich project will have multiple questions that beg to be answered, right? It's not just one way of looking at the data. Let's do the parametric test, the non-parametric test. What if we exclude the outlier? What if we don't? What if we include other variables to actually combine into a bivariate dependent variable, right? Those kind of things we want to be thinking about. So I think we need to change both the introductory class in terms of teaching more of this in the introductory statistics class and infusing it throughout the curriculum, but also in working with data science, whether it's us or speaking with our colleagues in CS and other fields, we need to encourage them to infuse statistical thinking into it. For some of them, that involves learning it themselves. But I will say, from my own personal experience, if I had to summarize this and offer advice for preparing students, for many academics, and I don't know the audience here who we're speaking to, but the best thing we can do to prepare our students, right, to be business analysts or data scientists is to prepare ourselves. And that's been my experience. right? So find some projects that push your skills beyond what you're comfortable with. Find a way of making sure you're up to speed on the tidyverse if you're using R, right? Listen to talks, find industry connections. I know a lot of people ask me about, oh, we want to start a data science program at my university. And I think the best advice I give is speak with folks in industry in your area, find out what kind of jobs your students might be filling in the future, and make sure you're teaching them, training them in what they need in order to fill those roles. All right. And my last thought, so I think I have responsibility in statistics. One of my professors at Carnegie Mellon, Steve Steinberg, I never really appreciated this when he said it back then, but I recently read one of his articles, and he said, my advice to budding statisticians is simple. Statistics is an exciting field. I think we as statisticians need to keep reminding people of that. He always talked about the excitement of discovery with data, and I knew what he was talking about. But the problem is when we teach and when we communicate, we're a little too pessimistic, right? We often tell people what we can't do, but what we should do is tell people what we can do. And so, I give this anecdote with the academics that I talk about data science with. Imagine a situation when you want to hire someone and you're debating between a computer scientist and a statistician. And a computer scientist, gets the task, has to calculate the return on investment next year. And the computer scientist quickly goes through the data and comes back and says, next year I predict a return on investment of our company of 2.4%. Great. CEO gives the same assignment to the statistician. They may spend a little more time working with the data because they're not as good with it. They come back and say, well, I want to know whether we're assuming we're going to do the same marketing strategy as last year, or are we trying something new? And can we assume that? And they ask about all the assumptions. They come back later and they say, well, assuming the assumptions are true, I'm 95% confident that the ROI is somewhere between 1.2% and 3.8%. And when someone presented those two scenarios to me, it made it clear to me why the CEO is going to prefer that computer scientist. And I know Roger spoke to this as well. Let's make sure that we tell people what we can do and what we discover. And if you have 30 seconds to convey your message to your CEO, make sure you're talking about what you discovered and the excitement of it. You should be doing the work on your own to make sure there aren't problems with your analysis. But if there's minor assumptions that need to be met that you think are probably okay, that's not what goes in that 30-second presentation, right? Just look at it yourself and make sure you're comfortable with it. And if there is a limitation of it, you will have to talk about it. But in a 30-second talk, let's make sure we focus on the excitement of what we can do and not what we can't. I had a student once who raised their hand once in class and said, Professor Posner, I was talking about study design and picking apart studies, and they raised their hand and said, Professor Posner, I just want to know, have you ever read a study that you agree with? Because I spent so much time talking about how the assumptions were violated and it wasn't random and et cetera, that I realized I think I was doing a disservice to my students. Rather than talk about what we find from this study, I asked myself the question of, well, do these limitations invalidate it, or do they just inform what else I might want to know? And if I, as a parent, had to read this study and make a decision about, do I give vitamin K to my kids, which was a decision I had when my kids were really young, I need to be able to make a decision on it and come down on it and not just say, well, there's limitations to it. So, all right, that's my talk. I will gladly entertain questions if there are some.
Yeah, great. Thank you so much. We have one question that is, how does your program or other programs you know of deal with training people that will go into industry and a variety of types of business where you want to cover these concepts of regular data science techniques, but you also want to cover design of experiments? How do you know that programs are incorporating those two topics into the same program?
I think it's a good question. I can share a few thoughts on it, but I'd be glad to hear other panelists' thoughts as well. My sense is that students who are going into data science analytics programs, there's tons of programs out there, and they're often really different. If it's hosted in a statistics department, it's going to be different than it's hosted in a CS department. And knowing what you want is helpful when you go into a program like that. Some of the programs, I'll say, just look like they have slapped a new name on an existing program already. And I can say, as someone who, we have a master's in applied statistics, I had some math faculty in our department say, why don't we call our new, some of the new major we have in statistics, why don't we call it statistics and data science? And a couple people said, that's a great idea. And I said, well, what are we including about data science that's not already in statistics? And they couldn't answer that. And I came back to them and said, here's my thoughts on it, and we're not covering that. So unless we cover that, we're not data science. So I think it's important to look into the programs that they're going into, because there really is a difference in what's covered there. And again, if you want to be more of the analytic person, do more on the statistics side. If you want to be more of the computational person, do more on the CS side.
Okay, great. We have one follow-up question to that. What courses are offered in the Villanova Data Science program?
So we don't have a data science program yet. We've been talking about it. We actually have data science courses in 3 different places. The CS department has a few of them. The statistics department has a handful of them, and our business school has a Center for Business Analytics, and they have some as well. So it's actually 3 different type of courses you're going to get at different institutions. And it's actually been really fascinating, the students that take courses outside of their home program. They actually say they get a lot out of it. In my class on Intro to Programming with R, they really get into more of the R coding and thinking about why you're doing graphs in a certain way and the statistical thinking that goes into it, not just creating a graph and thinking about the consumer implications.
Great. We had one comment a little bit earlier. There isn't a question here, but it might be something interesting that the panelists might want to comment on. We've been talking a lot about business analytics and data science in support of new product development, process engineering, and other engineering functions. I'm teaching business analytics in a business school, and we're trying to convince marketing and finance majors that they need these skills to succeed in their functions as well. So no question, but if you have a comment on this. I'm not sure if anyone on the panel has experience with a lot of different industries. So we've certainly heard a bit Dow and DuPont with the industrial side or process development or process engineering, but I'm not sure if the rest of you have experience in finance or marketing and so on.
They need it.
Yeah,
I spent a year and a half at corporate finance at GE at corporate headquarters, and the best people in marketing are data-driven people. And in finance, finance is fundamentally involves probability and statistics. You're dealing with things like risk, and you're either doing it by gut feel and intuition, or you're doing it through analytics. So marketing and finance in particular really need it.
Yeah, and I, as a statistician at DuPont, I worked with our chief economist frequently, and he had some background in general statistical methods, but wanted to make sure that some of the conclusions he was making were fair. I did a lot of work on understanding how to deal with the different markets and projecting silver, precious metal prices, and how we were going to build that into our product development portfolio, because a lot of our electronic materials use precious metals, and so dealing with the market fluctuations on that. And so yeah, the same statistical methods can be applied, or the same computational methods can be applied in economic or economist kind of work. When it comes to marketing, I probably did a lot of my work in marketing, and it was a lot more of the statistical thinking in the last 10 years, I'd say. It's a lot more of the statistical thinking and the problem solving and the listening and the project management and those kinds of skills than it really was in needing for coding and things like that. However, some of the new developing prototypes very quickly required a lot of being able to quickly program things, quickly do cloud computing, so we had statisticians and computational folks and cloud computing folks working together to make rapid prototypes to test the market. So while it might not be, it depends on the product types that you're trying to market, whether you need that, but I think, same skills needed, different application.
Well, it looks like we're at the end of the hour. I'd be happy to wrap up and say thank you to Kim, Roger, and Michael, and our host, Jump. And I hope you enjoyed this webinar, and we may try and do one in the spring.
Yeah, thank you so much, everyone, for attending, and a special thanks to George, to Michael, to Kim, and to Roger for speaking with us today. And certainly get in touch with us if you have any further questions. You're welcome to send an email to academic@jump.com. I'll type that in the chat as well, and I can get you in touch with any of our panelists if you had further questions. So thank you so much. And if anyone would like to join the Business Analytics and Statistics Education Interest Group through the ASA, I hope that you will. That's a great group, and that's where this panel came from, and we'd love to get more involvement there. Thanks, everyone.